Let P be a square matrix. P square is equal to I minus P. Alpha, beta, gamma, delta are natural numbers. We are given relations P power alpha plus P power beta is equal to gamma I minus 29P. P power alpha minus P power beta is equal to delta I minus 13P. We need to find the value of alpha plus beta plus gamma minus delta. Options are 18, 22, 24, 40. A simple question on matrices. So first what we are going to do is we are going to solve these two equations, namely the equation p power alpha plus p power beta is equal to gamma I minus 29p, and we are going to write p power alpha minus p power beta is equal to delta I minus 13p. Let's add the two equations. This will get cancelled. So I get 2 times p power alpha is equal to gamma plus delta times I minus 29p minus 13p will give me minus 42p. Divide by 2, we get p power alpha is equal to gamma plus delta divided by 2 times I minus 21p. So keep this as relation 1. Let us use this relation. P square is equal to I minus p. So we know that we are looking for a minus 21p, but p square has only a minus p. That means it should be a higher power of p. P power alpha should be more than p square. So let's square on both the sides. We get p power 4 is equal to I minus p the whole square. We know identity matrix is commutative with any other matrix. So we can write this as, we can use the identity. I square will give me I plus p square minus 2ip, which is nothing but minus p. Try to replace p square again as use this relation again and again. So we get I plus I minus p minus 2p, which is giving me 2I minus 3p. But we are looking for a 21p. So let me square this equation again. So I get p power 8 is equal to 2I minus 3p the whole square, which will give me 4I square, which is a 4I plus 9p square minus 2 2s are 4 3s are 12 minus 12ip, which is a 12p. Again replace p square as I minus p. So I get 4I plus 9 times I minus p minus 12p. So which when simplified will give me 13I minus 21p. So I have got p power 8 is equal to 13I minus 21p. Let us compare relation 2 and relation 1. Here we have a minus 21p here. We have a minus 21p here. That means LHS and LHS should be equal. That fetches me value of alpha is equal to 8. And I can compare the coefficient of I. Gamma plus delta by 2 is equal to 13. That gives me gamma plus delta is equal to 26. So by using this we have got the values of alpha and gamma plus delta. Let us use the same set of equations and try to eliminate p power alpha by subtracting the equations. So my first relation is p power alpha plus p power beta is equal to gamma times I minus 29p minus 29p. My second relation is p power alpha minus p power beta is equal to delta I minus 13 times p. Let us subtract the equations. So p power alpha will go, this will become, so I will get 2 times p to the power of beta is equal to gamma minus delta times I minus 29 plus 13 is a minus 16p. Divide throughout by 2, you get p power beta is equal to gamma minus delta divided by 2 times I minus 8p. This is relation number 3. We are given p square is equal to I minus p, and we found out that p power 8, when we found out p power 8, we saw it had a minus 21p. We don't need a minus 21p, we need a much lesser coefficient, minus 8p. So it will not be p power 8, it should be much lesser. So let us take p power 4 and p square and try multiplying them. We know p power 4 is equal to 2I minus 3p. So let me find out p power 6 is equal to our p power 4 is nothing but 2I minus 3p. 2I minus 3p is p power 4 and p square is I minus p. So this will give me p power 4 into p square, which is p power 6. So this when I expand 2I square will give me 2I minus 3pi minus 2pi will give me minus 5pi, which is minus 5p, minus 3p into minus p will give me plus 3p square. As we had done earlier also, let us replace this p square again as I minus p. So I get 3 times I minus p, which when you segregate, we get p power 6 is equal to 5I minus 8p. Let me call this as equation number 4. Compare equation number 3 and equation number 4. You can see a minus 8p here, you can see a minus 8p here. That means the LHS should be equal to LHS. That gives me beta is equal to 6 and gamma minus delta by 2 is equal to 5. So gamma minus delta is equal to 10. We already got the values of alpha and gamma plus delta. Alpha is equal to 8. Let me write here, alpha is equal to 8 and gamma plus delta is equal to 26. The question was to find the value of alpha plus beta plus gamma minus delta. So there is no need to find individual values of gamma and delta. I have alpha here, which is 8. I have beta here, which is 6. I have collective value of gamma minus delta is equal to 10. So 8 plus 6 is 14 plus 10 is equal to 24. So the value of alpha plus beta plus gamma minus delta is equal to 24, which is nothing but option C. A simple question using matrices where we need to understand only one concept, that identity matrix is commutative. It commutes with P. So IP and PI are same and I square is always equal to I, using which we get alpha plus beta plus gamma minus delta is equal to 24, which is nothing but option C.